Let's get a look here at problem number 1 on this sample exam. What we want to do here is to maximize this function here, p equals 7x plus 7y, but subject to these constraints, right? This line, and of course our two non-negativity constraints. So we know what to do here. We are going to, let's name these. This will be constraint 1, this will be constraint 2, and we're going to graph these lines. Let's do that. We'll get a little table here, x and y, and when x is 0, right, when x is 0 here, 2 times 0 is 0, so this term is gone, and we'll get y equals 10. And then when y is 0, right, when y is 0 here, that term's gone. We get 2x equals 10, so dividing 10 by 2, we get 5, so x will be 5. And in line number 2, the table again, x and y, and when x is 0, all right, let's go to line 2 here. When x is 0, this term goes out. 2 into 8, that'll give us a 4. And then when y is 0, that term goes out, and we'll get x is 8. So let's plot these points. And when we do this, we know we're going to draw a pretty good-sized coordinate system. Maybe that's big enough, we'll see. X and y. And now, on the x-axis, our biggest number, let's say on the y-axis, let's go there first. Our biggest y, we've got 10 here and 4 here. So let's draw this. Maybe the 10 will be up here, and the 4, that's about halfway down, right? Halfway down would be 5, so let's go a little bit below that. Maybe that's the 4. And then on the x's, let's see, the biggest x we have, there's a 5 and there's an 8. So the biggest x that we have is an 8. Let's put it out here. And 5 is a little bit more than half, so maybe there. And now let's draw these lines. So what do we have here? The 10 on the y connects with the 5 on the x, right? Here's a point on the first line, 0, 10, that's here, and that connects with this point, 5, 0. So the 10 connects with the 5, so let's get that line. Maybe this right here, and then in this line, the 4 on the y connects with the 8 on the x. So the 4 on the y with the 8 on the x, we've got only 2 lines, so we're not going to get mixed up here. This is what we have now. This is line 1 here, right? That's line 1. That's this line here. Let's make a note of that. That's line 1, and this here line is line 2, and where we are then is this, is in this place here. These inequalities here, x greater than 0, that's all over here. Let's mark that. That's all over here. Right? All the x's to the right here are greater than 0. And this one right here, the second one, this one here, y greater than 0, that's everything up here, right? All the y's up there are greater than 0. And in this first line here, if we run a test, let's do that right here. Why don't we run a test? Let's say we test this point, 0 and 0. So if we put 0 in here and in here, we're going to get this. 2 times 0 plus 0 less than or equal to 10. And sure enough, 2 times 0 is 0. 0 plus 0 less than or equal to 10. That's true. So everything on the 0, 0 side of the line, here's 0, 0, everything on the 0 side of the line gives us a true statement. So these solutions to the first inequality are to the lower left. So we'll get everything here. And because it's a less than, it's going to work the same way for line number 2. We're going to get everything to the lower left. If it was a greater than, we'd be up here on the right. But it's a less than, so we'll get everything here. So what we're looking at now is this region right here, right? Everything in here, and then everything down here. This is our feasible region. So we've got these corner points. This one here, this one, and of course we have this one, but 0, 0 is not going to give us a max, so I'm not even going to bother testing that one. Now, what are these points? Well, this one here at the top left, this one here, we have that already. That point there is 0, 4. This point here, that is 5 and 0. We need to get this point. Now this point here, we're going to use line 1 and line 2 on our calculator, and what we're going to do is we're going to end up doing this. We're going to RREF, okay, line 1. Let's go over here for our line 1. We'll go over here and we'll get our line 1. Looks like it's going to be 2, 1, 10. So let's put those numbers in, 2, 1, and 10. And then line 2, well, we have only 2 lines, so how about 1, 2, and 8? So we'll be here at 1, 2, and 8. And now, when I RREF this, I'm getting this to be, all right, there's our 1001 that we should get, right, our triangular form, and I'm going to get 4 and 2. So let's take a look at that. What is that possible? This means that x is 4, so look over here. Bring it over here. That's supposed to be a 4. We'll bring it down, right? This is 0 over here. This is 5. We're to the left, so that's reasonable. That could be a 4. And then up here, this RREF says that y is 2. So let's just look at this. We bring it over. This is 0. This is 4. Yeah, that's reasonable. Okay, so it looks like we might have a reasonable solution there. So we're going to have this point is 4 and 2. And now let's make up our table where we're going to check these. We'll get xy, and we'll get p equals 7x plus 7y. And then let's start here at the top left and just move to the right. This will be the first, the second, and the third. So with 0, 4, we'll get p equals 7 times 0 plus 7 times 4. That's going to give us 28. And then let's move down here to this point, right? 4, 2. So when x is 4, y is 2, we'll get p equals 7 times 4 plus 7 times 2. All right, this is going to be 28 and 14, so that should give us a 42. And then, moving down here, we're going to get a 5 and a 0. All right, so when x is 5, y is 0, so this will give us p equals 7 times 5 plus 7 times 0, that's 35. So that 42, that looks like the maximum. So let's write our conclusion. Now I'm going to do it down here near the bottom. So I'm going to say P is maximum at 42 when x is equal to, all right, now follow it back up here. 42, x is 4, and y is 2. When x is 4 and y is 2.